So this is our last video in the geometry review, and we're going to be talking about a trapezoid and then a trapezoidal prism. Okay, so the formula for a trapezoid is a little more complicated. First we need to know how they get labeled on the diagram. So you have and the definition, I guess. So a trapezoid has two opposite sides that are parallel to each other. The other two sides, they can be, whatever. They're just not necessarily parallel, okay? So you have to have at least two opposite sides that are parallel and then, the rest of the figure. So you could have something like two parallel sides and something like that. That would be considered, well, if I'd drawn it right, that would be considered also a trapezoid. Okay, because you have a parallel side here and then opposite a parallel side. Okay, we call those parallel sides length 1. Remember, that's a subscript, so length 1 and then length 2. Usually the smaller one's length 1, but it doesn't really matter. And then we have a width. Sometimes it's also called the height, which it would be if you dropped a perpendicular or put a perpendicular line that was perpendicular to both L1 and L2. And that's going to be the W. Okay, so let's say an example, we have 16 feet for length 1 and 20 feet for length 2 and a width of 10 feet. Let's keep it simple. So to find the area, it's going to be the width, 10, over, and then it's going to be 16 plus 20 divided by 2. Did I say over? I meant times. So it's the width, 10, times, and then length 1 plus length 2 over 2. All right. So then we follow the order of operations. We'd get 36 over 2, which is going to be 10 times 18. And that's going to be 180. Now, what's the measurement going to be? Well, we're measuring in feet and we're finding an area, so it's going to be in square feet. Okay, now let's go to the prism. So sometimes this is a little hard to picture. I was trying to find a real-world example, and I thought this one was pretty good. So you take those trapezoids and, pretend like it's a trapezoidal shape cracker, and you stack them up, right? So on this suitcase, you can see there's a trapezoid here. Whoops. There's a trapezoid here. And then on the bottom, on the other side, there's also a trapezoid. But each of these sides are rectangles, okay? Make sure I'm telling you the truth. Yeah. Okay, so there are other figures that look similar to the trapezoidal prism, but they're not. Okay, so you can also think of, remember we had that 10th, that triangular one. If you took the triangular one and you cut off the top. Okay, so what we do is we take the area of the trapezoid and then multiply it by the height. And the height is going to be how long that stack is. Pretend like you're stacking up the crackers, so turn my picture on the trapezoid, and that's going to be how many crackers there are. Okay, so you would just figure this part out and then multiply by h. So if we had the example up above where we had 180 feet squared, that was the area of the trapezoid, and then we had, let's say, a length or an h of 20 feet, then you just multiply that times 20 feet, and then you'd get 3,600 feet cubed. Notice that you have feet squared times feet, and that gives you cubic feet, or feet cubed. Okay? That's a volume measurement, so that's correct. All right, we will see more geometry when we go to work in the chapters.